you should be able to see my screen. Welcome to our webinar for Microsoft Defender External Attack Surface Management. I'm JT Wells, Senior Product Manager. With me are my co-host, Mr. Michael Lindsey, also Senior Product Manager. We are part of the Unified Security Intelligence team, which is a broader organization within Microsoft Security that focuses not just on threat intelligence, but security intelligence as a whole. And there's a lot of really exciting things that our team has in the works, not just what we're going to be speaking about today. Specifically, we're part of the Customer Experience Engineering Customer Adoption team. And what we do is we work directly with customers to ensure that we are getting very clear, very direct, and completely truthful feedback about our product. And so we act as a liaison between the product development and product management teams, as well as the customers. We're security practitioners. We come to this with an ample amount of experience, not just in the field and doing the kinds of things that the security professionals use our products for, but also the actual products themselves. We came along with the company RiskIQ, which was acquired by Microsoft back in 2021. So let's talk about why we are here today. Now, we have two products that are part of what it is that our organization does. Now, today we're going to be talking about Microsoft Defender External Attack Surface Management, but our sister product, Microsoft Defender for Threat Intelligence, combined, we are looking at kind of the whole ecosystem of cybercrime. And as it begins to continue to cross modalities, we need to develop more and more ways of not just exposing what criminals and threat actors are doing, where are they staging and setting up things, but we also need to turn that intelligence back on ourselves. We need to know what sorts of things are vulnerable, what is exposed to the internet, what didn't we know about, because if we can reduce our attack surface, we reduce the targets that these threat actors can essentially take hold of and begin leveraging for their attack campaigns. And so the harder that we make it, we are really following security best practice by defense in depth and reducing your attack surface and least privilege and whatnot. So really what we need to do is we need to leverage as much security intelligence as we can in 360 degrees of sight. It's not just what the threat actors are doing, how they're doing it, or what tools that they're using to perform these sorts of attacks, but what do we look like? What do we present to the public, to the outside world, to the threat actors, and to everybody else that would make us as an organization a prime target, or something that quite possibly would be more apt to be attacked by threat actors or criminal organizations. So the one main thing here that I think everybody knows, especially in this day and age, is that the attack surface is growing. And it grows at now an unprecedented scale. Because if we think about this in the terms of maybe a decade ago, the perimeter of security was the firewall. Everything within inside of that firewall had very well-defined, very mature practices and a lot of structure. There was product maturity in firewalls and network access control and permissions, and years and years of experience of figuring it out the hard way, how to do security right. But the cloud came along and disrupted everything. And now the perimeter at which organizations interact with their customers keeps going further and further outwards. And it is doing so at this amazingly fast scale with infrastructure as code, with the rapid expansion and contraction of workloads in the cloud. Enterprises really are just having this amazingly hard time to keep sight of where all of these things are at. And if we think about this, even in the most simplest of contexts, before, security kind of acted like a gatekeeper. They had the keys to the castle and they knew what got in and what got out of that organization. Now you have various teams that are in control of these workloads. They own them, they're responsible for them, they're the ones that put them out there, and they're not under security's purview, nor do they have to essentially get approval in a lot of cases to deploy these solutions out into the ether. And so in doing that, security is really struggling to try to keep up with these organizations. And this is why external attack surface management is really so important, because if we only look at what's on the inside, we're really missing this entire world of our attack surface that, quite frankly, is the first thing that attackers see whenever they are reconning an organization to begin their attack. So where do we sit inside of this ecosystem within Microsoft? So we have Microsoft Sentinel, which I believe most everybody is very well versed and aware of. It's an amazing product. It serves as both a SIEM as well as a security orchestration platform, and is a huge repository for logs and information about devices and users and things like that within inside of your organization. You have Microsoft Defender for Cloud, which is meant to secure your infrastructure that is not just in Azure, but in all clouds, as well as Microsoft 365 Defender for securing your end users and devices and making sure that information and access is given out and utilized properly. And when things are anomalous and not quite necessarily acting in the way that they should, then a lot of these other solutions all team together to help defend an organization. But how can you defend what you don't know that you own? You can't deploy an endpoint solution to it if you didn't even know that it was yours. You can't put a control around it, maybe put it behind a firewall or protect it or deactivate it or decommission it. If you didn't know that you owned it, you wouldn't know to protect it. So this is why it is so important that we now exist within this greater security portfolio to help secure organizations around the globe. And so if you were going to take away anything from this, this is really, I think, where a lot of the really important key takeaways about Defender for External Attack Surface Management comes into play. So we discover digital assets from the outside in, meaning we see the world as the attackers see them, but also essentially how the rest of the world sees it. But we monitor this continuously. We're looking all over the internet all the time. And so we not only need to identify what's out there, but we also need to continuously analyze it. What's changing about it? Is there new vulnerabilities that just got released or that the world just became aware of? And are those vulnerabilities facing your outward internet external attack surface? Being able to identify vulnerabilities and to help prioritize them. Where are areas within your organization that essentially have the biggest amount of risk? And what can we do to help other teams within our organization prioritize fixing and remediating these things? Because nowadays, security teams are not the ones that are fixing these issues. They're trying to work with IT teams and cloud teams to essentially help themselves to secure this organization. And so oftentimes the security teams can help them by supplying information to say, I know we're trying to get you to fix everything all at once, but concentrating on these things, then these things, and then these things is really the way that we're going to move the needle in reducing our risk as an organization as a whole. As well as talking about when we earlier discussed threat intelligence, we surface attack surface insights and remediation strategies that come from a numerous amount of sources, including our very own research and threat research and threat intelligence teams. So we're looking at the threat actors and knowing the tooling that they're using, and also we're able to provide better context about what exactly is it that they're doing and how are they doing it, and what strategies can we leverage to better defend ourselves. And we package all of that information up into this platform. And then being able to pair that with, say, Defender for Cloud, this really now then takes all of that capability and extends it out into this multi-cloud approach that so many of our customers are now utilizing. Of course, they want to diversify their portfolio. They want to be able to leverage clouds, maybe because of the talent shortage or because they just already had maybe an organization that they acquired with workloads and processes that are already built into these clouds, or maybe they're just trying to use it to diversify risk. Whatever the case may be, now we're extending that security capability across all clouds and to help improve that security posture and compliance across the entire organization. And so all of the ability to be able to see and map and protect all of your assets across all clouds and different workloads now gains from this visibility so that we can help better defend all of the assets, whether we knew about them or we didn't. Michael, Lindsey, how about you go ahead and fill them in about the strategy that we are leveraging for kind of pressing further into this multi-cloud security.
Absolutely, JT, thank you. So first of all, the Defender for EASM solution is built in Azure. It's native. It's simply a resource that you can deploy and get up and running very, very quickly. On top of that, since it is agentless, we don't just see those pieces of infrastructure that are specific to Azure, but we also have visibility into multiple cloud providers, whether you're using Azure or one of the competing hosting or cloud operations. And in addition to that, we'll also discover things that aren't in the cloud at all. So if you host your infrastructure, maybe in a data center that your organization owns, and you're also using one or more cloud or hosting providers for your infrastructure, we'll discover all of those assets as well. And this kind of gives you that outside in view of exactly what an attacker would see, along with all the metadata that we can discern from those assets, to give you a picture of what your security posture looks like to the internet at large. GT?
Thanks. Right, so let's go ahead and get into this. So Defender External Attack Surface Management is really tackling these main challenges that security teams face today. I have more than enough stuff that I could possibly track that's growing out in the cloud and then on the internet. How do I find all of it? And then whenever I do, I'm realizing that there's huge amount of risk that is being surfaced from finding all of these things. Some of it may be old, some of it may have been something that we didn't even know about, and it's just sat there and deprecated over time. How can I help the teams within my organization prioritize risk? Because it does cost time, effort, resources to mitigate or remediate these issues. So we need to prioritize this vulnerability and risk, and really be able to start to tackle the biggest threats to our organization as fast as possible. And in doing that, the attack surface visibility of being able to find these unknown, unmanaged, completely orphaned assets that are out there really help reduce the attack surface. So we're taking away things that attackers would readily leverage and utilize as a path to escalate privileges or move laterally within an organization. By doing so, we're also helping to shore up compliance. So think of things like GDPR or other compliance and regulatory frameworks that we need to adhere to. We really need to be able to find these assets that surface for any number of different reasons, one of which Could be human error. Somebody, within a certain team really, had the gusto to go out and spin something up, and they were doing so with reckless abandon, but, all the best intentions, and that configuration really isn't, up to the standards of our organization, or they just didn't tear it down whenever they were done with it. There could be all kinds of different things out there that get left, whether it's test dev, something that came along with a merger and acquisition, all sorts of different skeletons in the closet, if you were, exist within organizations' attack surfaces. And even the best of the best always find things that are shocking, completely surprising, because we're all humans. We make errors, and security really is about creating this defense in depth strategy. And so the more that we can protect what things that we have or that we are responsible for, the better as a whole that our organization will be. We have to kind of protect ourselves from ourselves. And so these human errors are always going to happen. And if we can find them faster than the attackers can, then we really are helping ourselves from future impacts to the organization. So here's the key things that we do. We will discover your internet-facing attack surface, find assets and resources you didn't know you had. Now, this is rough. This is not a extremely technical number, but on average, most of the organizations that we've worked with in the past, even prior to us being acquired by Microsoft, was that most of our customers found about 20% more than they thought that they had. Initially, they usually, started off with a pretty good list of, here's all the things that we know that we have. Here are our ASNs, and here are our known domains. Here are the net blocks that are delegated to us, or we're leasing, or these are things that we own that are in our data center. We generally wind up finding about 20% more. Now, give or take, it depends on the organization. But the larger, the older, and the more active, as far as M&A is concerned, an organization is, this number starts to balloon dramatically. By discovering this exposed attack surface, this is really where things start to get very interesting. Because once you know that it's there, then you can actually do something about it. And as it changes over time, whether that particular vulnerability is being mitigated, maybe a server is being updated, or it's being deactivated, whatever the case may be, even if it's for something that would be as I wouldn't say benign, but an expiring SSL cert or a domain, those continuous monitoring scans continuously update these assets as they go along. And as new vulnerabilities surface, we help identify those as well. But this is one key thing that I want to make sure we make crystal clear. Because there is no agent, we're not what you would call vulnerability scanner. So we don't go into an asset, we don't log in, we're not inside of a registry or accessing from the inside out. There are plenty of amazing platforms that are really solidly good at that. And there is a need for those. They absolutely are necessary. And we'll talk about some areas where we can actually optimize vulnerability scanning. But in the sense that we are just passively scanning the internet and we are looking at the exposed attack surface in a way that an attacker would when they're in the reconnaissance stage, you have to remember that we are not penetrating these assets. So we are seeing exactly as they are seeing prior to the engagement of an attack. And then lastly, once you have this composite attack surface, this inventory as we call it, you can help prioritize exposure and the exposed resources by figuring out what things we're going to dedicate our time to, whether that's moving away from a particular technology. Maybe you're migrating from one particular flavor of web server to another, or maybe it's you're moving from cloud providers, or there's a divestiture within the company. Being able to prioritize where your focus or attention is at really can help your team optimize your strategy because again, having a broader picture then allows teams to fix problems across their organization, not just at a piecemeal scale, but at an organizational scale. We've seen organizations, for example, that have had really huge problems with, say, like a web framework. So if you looked across the entire organization and said, where is the highest concentration of critical vulnerabilities within your organization? One in particular that I can think of was a financial services customer, and PHP, surprisingly, was where they had the greatest amount of risk. But they had versions all over the place, some of them up to date, some of them way behind. But they were able to take that and say, okay, as a concerted effort, we're going to focus all of our attention on really solidifying and hardening everything that is running PHP, or deactivate it if we can find a better technology. In many cases, that's really not a feasible solution, but as a whole, they dramatically improved their security posture by focusing all of their efforts on the area that was really going to make the biggest amount of difference to their organization. So as far as discovering vulnerabilities, this is personally one of my favorite areas, and I definitely want to allow Michael to talk about some other things as well. But we'll explain a little bit of the technical aspects of how we go about discovering these things. But we have sensors and crawlers that scan the entire internet all the time, everywhere. And we have fully baked virtual user internet facing profiles. So we look just like the regular web traffic that's out there. We egress from the right places, presenting the right browsers and screen dimensions and fonts and everything else. In doing so, we're actually accessing the web in a way exactly as this an attacker or a real user would. And we get to understand these unknown assets and services that may still be online, because we can discreetly link assets together in many different ways. It might just be through DNS, it might be through whois information, but it could be things such as SOA records, or it could be shared SSL certs, or a number of different things. But a lot of times what this will do is this will help us find the external, very fringy outward parts of an attack surface. And that helps teams discover stuff that they had no idea that was part of their organization. And through that, we build this accurate, up-to-date catalog of your organization's resources and assets. Michael?
Yeah. So once we've built that catalog and we've discovered your external attack surface, we have the ability to help organizations prioritize vulnerabilities, because in most cases we will have fingerprinted the manufacturer of a product, as well as captured and fingerprinted the version of the product that's running. So it's a very simple step for us to be able to cross-reference those manufacturer products along with any hardware or software versions that are running against CVE databases, and provide back to the users of the platform some prioritization around what to go fix first. And I think that's a key feature of the program, and we'll see some of that in some of the default dashboards here coming up. JT?
All right. So now when it comes to securing your infrastructure, you've got this data. Now you can do something with it. You can bring that external facing unmanaged catalog of resources under management, whether it's in the cloud, it's in your data center, or it's somewhere in between. We have recommended actions to mitigate specific risks and help close the gaps in the perimeter and improve your security posture. Now, there's also a subtlety and kind of even a sub-layer to this, that we have many organizations that have to treat different parts of their attack surface differently, maybe because of privacy and data sovereignty, due to things like GDPR. Maybe you're a global organization and you have to treat different areas of the world differently for many other reasons, not just privacy, maybe areas like China or parts of the Middle East. Having this vast amount of visibility now allows organizations to label or catalog assets within their organization, thereby essentially providing ownership and or responsibility of these assets to separate parts of your organization. Maybe you have some semi-autonomous security teams within your organization because your org has acquired many companies over time, and each one of them has to handle security a little bit differently. So now you're not only able to close the gaps as a whole over your entire attack surface, but you can disseminate this information to other teams within your organization and do so knowing that they're getting the context of, why am I being told about this? Should I be doing something about it? The platform allows for a lot of different ways to slice and dice this data that makes sense to your organization. So I'd seen in the chat, we were getting a lot of questions about identifying vulnerabilities and things like that. And so this is really, I think, where Michael and I can help cover a lot of those questions. So we observe the internet through the eyes of the attacker. And I know that we've said this many, many times, but we can't stress the importance of that. The platforms like the vulnerability scanners and threat and vulnerability management platforms of the world, they are oftentimes given a known good, kind of a list. Hey, we know that we own this. They do have some discovery mechanisms built into them, but oftentimes it is kind of worked from this insider point of view. So if we know that this particular server accesses this database, it's on this other server, there's discrete internal connections between those things that these platforms can make sense of. But whenever you're looking at it from the outside, and sometimes that doesn't quite necessarily make as much sense. But there are other connections that those vulnerability scanners wouldn't be able to observe unless they actually fully rendered a web page or fully traversed all of the DNS records and made sense of all of it to be able to understand what components and what things are being built as part of that page. And every single scan of an asset, whenever we're crawling, is a full capture of from the time that a browser would open to the time that it closed. So every header, every image, every DNS request, every third-party resource that's loaded in as part of a page, think like scripts and web fonts and all kinds of other different things. We capture all of that so that we have this vast trove of data to start picking out of to say, oh, hey, we saw something interesting here. And that indicates that this module from this CMS or this web server is actually being used. And so utilizing URI folders and headers and cookies and certs and everything else helps us to identify technologies on these assets in many different ways, and in ways that a lot of times these platforms just wouldn't be able to. And I have a kind of a story in particular about one of those. We also help discover those orphaned assets that have deprecated. So it's really important to identify these things that once we know that it's ours and we have to do something with it, to be able to discern like, hey, this is extremely low hanging fruit for an attacker. Like every Metasploit module out there, instance has something that could probe this particular technology. There could be a number of different ways that an attacker could utilize some commodity malware to try to get within and compromise this asset. So finding these deprecated assets and identifying essentially how far down the rabbit hole they've gone really becomes very important. But then we also have the ability to target very specific types of technologies. Things like industrial control systems or building control systems, IoT, you name it. We have many customers that really have now embraced this whole idea of the Internet of Things and the ability to monitor kind of their entire operation from this bird's eye view utilizing the internet. But as humans, we're all victim to making mistakes. And so sometimes these platforms are exposed to the internet, but if an attacker gets a hold of them, could wreak immense havoc on an organization. And so it's extremely important to expose these technologies and then put them behind a security control or revoke their their exposure to the internet or mitigate it in some form or fashion. One thing in particular that kind of stands out here to me is that a financial services customer that I had worked with a while back had a problem with a Telerik UI vulnerability. They had utilized a internal scanning solution that essentially went through all of their source code, went through everything internally, and could not find it. It's not that it was a shortcoming of the platform, it just simply wasn't designed to find it. And the only way that they were able to find it was through us. We were able to traverse the entire URI path of every web page that was being loaded. We were able to see that it was a module that was, that it was being loaded as part of the ASP framework and technology. And in doing so, we were able to identify that these were areas that needed to be focused on, and these were ultra critical vulnerabilities that were adjacent to areas where card data was being processed. So we all know PCI being a very well known but also notoriously tricky framework to work within. Sometimes, it takes the combination of multiple solutions to present the best security options. And this is by far one of the best strategies that we've been able to see within organizations is using our platform to identify these assets, using other platforms to be able to then enumerate them and enrich the data about them even further, so that all of this data essentially helps them prioritize what do we need to fix first so that we really move the needle with our security posture. Michael?
Yeah, so how does it work? So we've mentioned a couple of times that we're collecting information about various devices and software that's running on the internet at large. We do this very discreetly and in a safe manner, and we use what a user would use or an attacker might use. So we have web crawlers, and we visit websites just as a normal person would and collect information, which is kind of restating here on the second point. All of our interactions are very human-like in their nature, so they are largely almost 100% undetected by any security devices because we present ourselves as normal internet traffic. And then we have a bevy of active and passive sensors that are collecting just tons of data off to the side. And we'll show you what some of those data sources are here in another graphic. But I think I'm going to kind of reiterate something that JT pointed out earlier, is that a lot of modern web applications actually depend on a web crawler to actually load all of that dynamic content. And it's especially important for organizations that are subject to things like GDPR, where it's important that we understand how cookies are configured and the lifetime in which they're alive, etc. Along with things like having SSL TLS encryption on login pages. Those are the types of insights that we can provide by gathering data just as a normal user would experience in their own browser. JT?
Thanks. And so, as I had stated earlier, whenever we are performing a scan, we're capturing everything. So there's kind of a step-by-step process of how we render the DOM, and that is captured and utilized in the background for a number of different things, but also all of the other constituent parts of these pages, and even the absence of something may in fact be a signal for something interesting elsewhere. And we also hash the DOM of pages. So think about things like if there's a standard login page for an organization, being able to have a very quick model of that page then starts to become very useful whenever we are looking at threats abroad. So being able to realize, what does the standard login page for Microsoft look like? It has a pretty standard, look and feel. And as we start to see where the rest of this proliferates on the internet, if it's not on infrastructure that we know that an organization controls, then it begins to become very interesting. And this is really kind of the beginning of many capabilities, either currently or to come, related to Microsoft Defender for Threat Intelligence. But it starts with knowing, what do I look like? What does my attack surface consist of? And the architecture for our service as a whole is a kind of a microservice model. So all of these different data sets, which we'll show you, there's tons of them, are little microservices of their own. So if anybody has developed a web crawler, which many of us have, that is kind of an undertaking unto itself if you're going to do something that is going to be able to get past kind of the filtering services that many attackers and even services that are meant to filter out that sort of traffic, so you want to be able to bypass. But then we're collecting passive DNS, who is SSL certificate data. All of these need to be their own mechanisms, and then we bring all of this data all back together, including one of the most important ones that I didn't mention, which is our IP mass scanning data, where we essentially scan all of IPv4 looking for open ports. And this really becomes kind of the big canary in the coal mine for a lot of our organizations. Is there a telnet port open, or remote desktop, or something to that effect? Finding these sorts of things being left open, really start to raise awareness and get people very nervous. But as we continuously map out this, this graph of the internet, we build upon that metadata over and over again. So appending to that record now, we're looking at more than 12 years of mapping the structure of the internet, so that we can even roll things back. So if we wanted to look at whois data prior to GDPR, in many cases we can, or to be able to look and see, how has a particular asset or something, progressed over time. Has the the updating essentially kept up with the times, or was there a certain amount of time whenever this asset was essentially orphaned and forgot about? When was the last time that it was really under active management and security? That historical data becomes immensely powerful in the hands of an organization, not just to tell, why is this in our inventory and why should I care about it, but also, what can I discern from this? Where did it fall off the map? How can we fix this so that this sort of problem doesn't happen again? So here's the magical stuff. So we collect this whole body of data from all over, not just our active crawls and scans, but also passive data sources that we are collecting, our microservices, and then we pick apart a lot of these different things. So as we are rendering a page, we're pulling out response bodies and third-party scripts and all of these other different things. We capture billions and billions of web crawls a day, terabytes of passive DNS. I love our data science team. They're amazing. They handle so much stuff. It's really cool how they can make sense of all these data sets, because it's a difficult thing collecting all of this data, but even more difficult making sense of it and actually tying it back together so that you have this composite picture of what your attack surface as well as the rest of the internet looks like. Now, to be able to scale that, we really do need some really solid core data science principles, but also some machine learning that can be layered in to help either raise suspicion for our research and threat intelligence teams to say, hey, I'm seeing something new. Let's probe into this a little bit further. Really, what is this? But then, we even take that a step further and do full security research. And we have some amazing researchers that really drive down into the depths of, what we are seeing on the internet. One of our researchers that, unfortunately is no longer with us, Jonathan, was really one of the folks that discovered MageCart and really helped make that public. So our security research goes way back in being able to make sense of, but also to further develop intelligence based off of all of this data that we are collecting. And then once it's all married back together, then we can actually break it off into these data sets that we can do all sorts of great things with, not just for protecting your external attack surface, but also for threat intelligence and research of the attackers. And these data sets then become part of things like a derived data set that we can then utilize for more defensive postures. And especially you would see that in Microsoft Defender Threat Intelligence, where we're seeing something, having phishing or malware being hosted upon it, or maybe it's a typo squatted domain that we know that an attacker is using for malicious purposes and many things like that. But if you see this whole trajectory of this data from all of the separate disparate sources of collecting it to where it's now massaged together into usable, scalable blocks that both our platforms can leverage, now it starts to really make sense how both Microsoft Defender External Attack Surface Management as well as the Microsoft Defender Threat Intelligence essentially builds upon this data for security teams across the globe. Michael, since you really have, and for those of you that are on here, Michael, you've really kind of wrote the book, so to speak, on helping customers get the most value out of MDEASM. Can you help kind of explain this onboarding process and where folks can really start to gain the most value out of the platform the fastest?
Yeah. Thanks, GT. So there are 4 stages in operationalizing the EASM. The first stage being onboarding. And I want everyone to kind of keep a mental picture of that last image that JT shared. So if you kind of consider all of that data, all that collection is happening every day. It's 24 hours a day, 7 days a week, 365, right? And it's going into a very large, we'll just call it like a data ocean. And it's happening on its own autonomously. All the data is being collected. Now, when you onboard an EASM resource, we're going to talk about a concept called discovery here in just a moment. But that's really what's happening in the onboarding phase here. We actually have a couple of options, but we're going to create our EASM resource first, and then we're going to seed it with some data that is unique to our organization. And there are 2 methods for doing that. First of all, we have pre-calculated the attack surfaces for tens of thousands of large organizations. And one option is to select one of those pre-computed attack surfaces from a set of seeds that is a good start for many organizations. For more complex organizations that have a lot of mergers and acquisitions and divestitures, or just would like to have multiple instances of EASM running representing various lines of businesses or brands or parts of the world even, we have the ability to select discovery seeds that are specific to those entities that we'd like to keep separate. And there are some good reasons for doing that in certain cases. So once we decide on those seeds, we'll perform a discovery. That's not illustrated here on this page, but we'll talk about discovery here in just a minute. But those seeds are what are used to query that large data ocean, if I can use that term, to determine what the attack surface is for any single organization. So that's really the first step in onboarding. The next step is to review what came back. So we have a brilliant data science team full of PhDs, much smarter than myself. And they will pull in assets into your EASM resource based on relationships off of those seeds and assets that they found. And there's a step in here where, you know, the algorithm is great. No algorithm is perfect. So, you know, there is a review step. And there will be a category of assets that the algorithm sees some connection to your organization, but maybe that confidence isn't high enough to say that it's yours. Maybe we're missing a little bit of institutional knowledge, but there are some connections and we want you to know about them to have the complete picture. So there is a review step that a user would need to take. Once we're certain that we've got the assets that are most interesting to us, that are part of our business and that we want to keep an eye on, we'll start a review on those in terms of risk. So what is, you know, kind of that software bill of materials? What hardware are we using? And this is where we start to analyze where the risk is in our environment and what actions we need to take to remediate some of those risks or mitigate. And this is kind of an ongoing process because I think as JT mentioned at the very beginning of the presentation, attack services for large organizations are dynamic. They're shrinking and growing all of the time as the business changes, as technology changes, as we make migrations from on-prem to cloud and back and forth. So this is really an iterative process and an overview of how you might think of operationalizing this in your programs like vulnerability management or maybe even third-party risk management. So I think that sums up this slide. JT, let's move on.
So we're going to kind of move a little bit faster, and these slides are purposefully wordy because wanted to leave behind some of this so that, you know, when this is over with, there's still more that you can dig into, but I think everyone's really ready to dig into the platform and kind of see what does this look like. So deploying this is really easy. If you can create an Azure resource, you can create an external attack surface management workspace. And so in doing that, this talks to what Michael was discussing about using either a predefined attack surface. The one thing that I'll stress on that is that these predefined attack surfaces are very false positive intolerant, meaning they don't take as many leaps of faith that would that a discovery mechanism would, or do they probe quite as deeply? Meaning it's a good glance and a good look at an attack surface, but really what it's meant to do is to provide you kind of an instant view of an attack surface while the actual discovery still happens. Regardless if you created a custom discovery from square one or you select a predefined attack surface, discovery still happens and assets still come in. But if you needed to find something right away or you really wanted to just kind of get a look and feel, utilizing these predefined attack surfaces is great. Whenever you do that, there's kind of this in progress mode. And so what this means is you essentially get that look while discovery is still going on. There are some small changes and things that you can do within your inventory, but you also get the ability to see the dashboards and everything else. But all of this continues to work in the background so that you don't have to essentially check back on it. Generally, a custom discovery takes 24 to 48 hours, sometimes a little bit longer, but also want to make sure to make note that even, and especially in the event of a larger attack surface, that first big discovery run, which can be set at a reoccurrence of daily, weekly, or bi-weekly, usually after about a week, is whenever we'll see kind of another big bump of assets come in, because our platform not only will kind of work through everything that we could find either by using a seed or a pre-built discovery, but then it goes out and it will fully crawl and click all the links and go as far and wide as it can, and then it goes and does it again for those very edge parts of it and continues to extend outward to try to find other nodes on the graph. So be expecting that this inventory will fluctuate just a little bit, over the course of about a week or so. But this is the part that I think that we all like. Let's talk about discovery. So if you start with a domain seed, say contoso.com, that domain is going to have a host, and that host is going to resolve to an IP address, which also belongs to an IP block. So the discovery is going to fully profile that fully qualified domain name. We're going to look up the whois data that we have, whether it's current or historical. We're going to try to find associated DNS with the hosts. We're going to be looking for records and all of these other different things so that we can start to find that extension. But then if we're looking on that IP block and that IP block also has a link, whether it's through whois or maybe the ASN is owned by the organization, we find other IP addresses. And on those IP addresses, we find other hosts. And so this is part of how discovery really works, because then we start to find all of these other assets that are related to an organization. And the algorithm really does a fantastic job of prioritizing and scoring essentially confidence on the ownership of these assets to an organization. And it just continues to find more nodes on the graph and extend further and further outwards. A few key terms real quick. A discovery group is a group of seeds. So if, say, we know that we own 8 domains, and we put those 8 domains in there, those 8 domains are a discovery group. But we could also do domains, ASNs, IP blocks, a whois contact. It could be a lot of different things. But that discovery group is a group of seeds, and those seeds are then utilized to discover new assets. And the reoccurrence of that discovery is called a discovery run. And how often that happens, of course, I think you understand, is the recursion. Now, the seeds that are part of discovery tend to be almost always domains, ASNs, and IP blocks. Now, we're working through some other ways of being able to seed discovery to try to be a little more creative. We've found some edge cases in many ways, but most organizations can find just about everything that they need, especially if they utilize the whois values, like a whois contact, an email address, or a whois organization. Now, there also could be instances where there are parts of your attack surface where you know for sure that you do not want that as part of your organization. Maybe it was a divestiture, maybe it was a spinoff, or maybe they have their own security team and that's their problem. You really don't want that in your metrics and you don't want anything to do with it. You can utilize what's called an exclusion. And this is all part of your discovery group. So the exclusion essentially says anything related to this asset, don't bring it in. Make sure that it is not part of the confirmed or approved inventory belonging to this customer. And so the exclusions work hand in hand with your discovery seeds to tell our discovery algorithm what to look for and what not. We're going to, continue to move through this, because discovery is really, the basis. Like, we really got to get this right. So putting in all of your discovery group information, determining how often you want it to go, and then including all of your domains, your seeds, your ASNs, your blocks, and all these different things, essentially starts everything off right. You can have multiple discovery groups. We've oftentimes seen that can cause a little bit of confusion. So it does help to essentially centralize everything into one discovery group. But if you really needed to logically separate those things out, by all means, utilize the multiple discovery groups methodology. And then we keep a running history of all of the discovery runs. And so every time a discovery run completes, how many new assets did we discover? How many assets were discovered in total? And so those updates continue to build up over time. Now, failed status, we see that sometimes, and it could be for a number of different reasons. Maybe there's some strange Unicode character and a whois or contact, or there could be a lot of different reasons. Maybe it's an internal one. It still usually works, almost always, as a matter of fact. And if it doesn't, then sometimes we'll see here in this very small image that 0 assets were discovered, but you don't have to do anything, because it will turn around and try again. And when it does, then you will see that it worked. The inventory, again, just going to lightly touch on this. We only have these asset types, and this really represents kind of the whole view of the attack surface of domains, hosts, also known as subdomains, pages, IP blocks, IP addresses, ASNs, SSL certificates, and whois contacts. Now you think, is whois contacts really an asset? Like, does this mean something to me? Yeah, it really can. Because if an organization utilizes whois as a standard way of creating ownership or some identification to an organization, if something new appears within your inventory and its whois record is completely different than the standard, this could be an indicator for a lot of different things. Maybe it could be that this resource was unknown or was instantiated without any sort of regards to control or company compliance, or, and we see this a lot, is that somebody used their corporate email address to spin up an asset, or they've registered a domain for some personal charitable or maybe side business of their own. We don't have a way to be able to tell if that is being used for a business purpose or not. And so, we really need to be aware that maybe this is something that somebody, maybe in a marketing team or an IT org, grabbed the domain and spun it up, but didn't follow proper procedure. Is it owned by the organization or it is not? And so this gives the inventory this extra dimension of being able to look across, this kind of whois attack surface to say what all is linked back to our organization and what parts belong to us and what parts don't. And so the inclusion of a whois contact is really kind of this pivot point for so many of these other assets. And then this is really important to stress, is that we have these asset states. The approved inventory, this is things that have absolute confidence. These are things that belong to you. So you know that it's part of your attack surface. The algorithm could very conclusively, really lean into this and say, yes, this is your asset. A dependency is something that you rely upon, but you don't own or you don't have control over. So say IP addresses for a hosting or cloud service. Monitor only could be something like a third-party dependency, a partner, or it's just something that you are fine with being aware of, but not necessarily, really needing it to be part of your security metrics. And then everything else that comes into a workspace generally falls into this candidate status. So a candidate is really just it has a connection to your attack surface, but not enough confidence for it to be labeled as an approved asset. Now, you could also say, hey, you know what, we need to take a look at this at some point. It could be something that somebody registered with their corporate email address, but appears that it really does not have a link to your organization, or maybe this is something that is brand new and you just need to park it into the status so that immediately somebody can realize, hey, there's something for me to look at. And then lastly, you have the ability to dismiss assets, whether that is, hey, we spun off this business unit, it doesn't belong to us anymore, or for whatever reason, the algorithm, kind of maybe extended a little bit too far, or got a little mixed up. Again, no algorithm is perfect, but ours is pretty good. And so sometimes you'll need to dismiss assets, and this is your way to do that.
JT, one more thing.
Yeah.
Before you leave that screen.
We're actually which one?
Didn't have time. Yeah, I just wanted to say that approved inventory is a special status in which those assets are going to be the assets that show up in the default dashboards right when you log into the product. So it's important to be cognizant of that particular state, and approved inventory status are actually the assets where billing is derived from. Which we won't cover in this presentation, but those two things are unique about that particular state.
Thank you. Michael, if you want, do you want to go ahead and talk through the slides that you prepared for the platform?
Yeah, let's
trying to locate where my.
Let's skip ahead to slide 46 and talk about a use case.
I don't have a number on mine. Well, we do have these wonderful dashboards. This is it here. We'll be able to drill down into that. We can touch on the APIs in a little bit, but we do have REST-based APIs for being able to utilize all of this data. And there is a lot of great info there. So, Michael.
JT, just in the interest of time, I think we could wrap it up in about 5 or 10 minutes.
Sounds good.
Okay.
So real quick, I just wanted to show you how to identify shadow IT in your organization. This is a very, very, very common use case, initial use case for a lot of companies, and it's finding those marketing websites that someone stood up in the cloud outside of normal IT process. GT. Next slide. Okay, so we can glean some of this information from the dashboards, but I'm going to show you how to do it manually because this is where a lot of the power from the platform comes from. And I'm going to show you in the UI, but in practice, you would likely execute some of these tasks via the API. So we're on the inventory blade, as you can see on the left, and we have the ability to add filters. So the very first step that I'm going to take in trying to uncover shadow IT in this environment is I'm going to look for all of the approved contacts. So those would be whois email addresses in my inventory. Next, GT. And we're using live data here, so I've redacted much of or all of the results for these slides, but I'm going to pick on this person with a first name of Paul, because most organizations would typically register things like domains and IP blocks and ASNs using an email address like domainadministrator@contoso.com. So this looks like a little bit of an outlier. Maybe Paul didn't follow the process. So I'm going to make note of that particular contact. And let's go to the next slide. So I'm going to reset my filters, and I'm going to look for just the assets in inventory that have a connection to Paul's email address. And let's once I click apply, I'm going to add a second filter, and I'm going to apply this filter to assets that typically are registered with an email address. So in this case, ASN's domains and IP block. And once I apply this filter, we'll see that Paul has registered a single domain with this email address. So that's interesting in and of itself, but I'd like to know all the assets that are also using that domain. So we would make a note of that domain. And here you can see that I've reset my filter to approved inventory, where the pages, the web pages, actually contain that domain. And I've got 36 results back. So Paul has registered a single domain, and we have 36 live websites. So what do I do with this? How do I action it? So I can modify these assets in a couple of ways. The first thing I'm going to do is select all of them, and I'm going to remove them, or I'm going to hit the modify assets button, and I'm going to move them from approved inventory to requires investigation. So it's something I want to come back and look at later. And I also have a create new label link down there, and I'm going to go ahead and label these assets while I'm doing this. So once I hit the create new label button, I'll be presented with this slide out here. And I'm just going to create a label name of Shadow IT, give it a display text of the same name, and choose a color. Now that label exists in the add label section, and I can select it. And once I click apply, what you'll notice is that all of those assets are now in a different status. They have a label on them, and these assets will no longer show up in my default dashboards, but through some other orchestration using the API, I can now query for these assets and potentially send them off to a SOC or another fix agent to go look at them more closely, see why Paul registered this domain, stood up these websites, and revisit the process, maybe give Paul some training, and see where the breakdown was in my organization that generated these shadow IT assets.
All right, I was in double mute. Thanks, Michael. So I believe that we have gone way over the allotted amount of time that we were given for this. We actually thought we had a little bit longer, but this is just demonstrating one of the many ways that we can utilize Defender External Attack Surface Management for surfacing insights about your attack surface. There are plenty of other ways, and we'll be able to provide a link to our blog to find and surface vulnerabilities of all sorts and kinds within your organization. We have a solutions GitHub repository with ways to create things like emails using a logic app for instances exactly like this. You know, if anything is returned from a query that says state equals requires investigation, and there's a label, you know, called Shadow IT or any label at all. And so we strongly encourage you to check out this information and continue to check back with us, because we have some really, really cool stuff that is getting ready to be released coming up here very, very soon. And we're so excited about it. But we wanted to thank you so much for joining us today and for allowing us to talk about things that we're really passionate about, and that is helping you defend your external attack surface.
Great, thank you. We did get a ton of engagement, and I'd like to thank the audience for asking all these wonderful questions. If your question wasn't answered, I would highly recommend you going to our Microsoft Defender External Attack Surface Management Forum at aka.ms/Microsoft Defender EASM community, and we'll have a subject matter expert take care of your question as soon as you post it. With that, I would like to thank JT and Michael for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security-community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security-webinar feedback. Thank you and see you next time. Goodbye.